In geometry, let's say for similarity, you need to know how to identify similar triangles and how to prove similar triangles. So question might ask you to prove that a pair of triangles are similar. So you need to know how to write the steps, which angle is equal to which angle, what reason, or which sides are proportional. And then there are three similarity criteria. You have to mention the two triangles are similar because of which criteria, and naming convention is also important. Then so there is a comparison with congruency, um, but anyway congruency won't be required that much, but anyway it's expected that you know what are congruent triangles and similar triangles also. Then there are three conditions that I've mentioned: triple S, SAS, double A or triple A. Double A, triple A will be the same thing, and you just need to write which condition you're using. Then for SAS, it's important to know that the angle that you're looking at, the pair of corresponding angles which are equal, they are supposed to be in between the sides which are proportional. If it is any other angle, then that is not SAS. Then there is a theorem called basic proportionality theorem that talks about in a triangle, let's say ABC, if I have any line, let's say DE, which is given to be parallel to one side BC, then there are two other sides of the triangle AB and AC. They are divided in the same proportion. So that means AD by DB will be equal to AE by EC. And the reverse is also true. If in this triangle it was known that AD by DB is equal to AE by EC, then I can say that DE will be parallel to BC. That is converse of this theorem. This is not very much applied in problems that I've seen, but you just need to know this theorem. Then another important theorem is about the areas of similar triangles. So area of two similar triangles is always proportional to the square of the corresponding sides. So you have to identify, if suppose you have a pair of similar triangles, then the ratio of areas of those two triangles will be square of the corresponding side ratio. And then you also may have questions on maps and models. So you would have seen some questions being asked, but it is little rare. But in case it is asked, you just need to look at the scale factor K. Scale factor will be the ratio of length of your map or model is to your actual length of your object or the ground or whatever it is. And then this is scale factor. Then suppose if you have to look at the area of your model versus actual object, then ratio of area will be square of scale factor. It is similar to the previous theorem that the ratio of areas of similar triangles is equal to the square of the ratio of corresponding sides. So even other than triangles, if any other shape are similar, which is to do with any map or model representing some real life thing, that is also similarity. So in that case, again, ratio of area will be, according to this concept, square of the ratio. So square of scale factor is k square. That will be ratio of area. And for volume, ratio of volume of model and actual object will be cube of scale factor, k cube. So you can apply that to solve questions. And again, conversion of units will be important in such questions. Centimeter square to meter square, something like that. Then we have a topic of loci. So you should know what is the meaning of loci or locus. And then there are some theorems. There are exactly three theorems which are listed here. You just need to know the meaning of these three theorems. And you will have questions, let's say MCQs, testing this theory, or you can have a question of constructions based on loci. So you should understand what are these three theorems, locus theorems. I've made a video on that before. And also what you need to know is, based on these locus theorems, specific to triangles, there are four centers of a triangle. So you can have something called centroid, which is intersection of medians, orthocenter, which is intersection of altitudes. Then we have circumcenter. Circumcenter is like, suppose I have a triangle ABC. I should be able to draw a circle which passes through all the three vertices of the triangle. Then the center of this circle is called the circumcenter of triangle ABC. And this point will be equidistant from the three vertices. Because in this circle, if this point is the center, then the distance OA, OB and OC are the radius of the circle, which are always equal. So if a question is like which point is equidistant from three vertices of a triangle, that is the circumcenter. And another is incenter. So suppose if I have a triangle, I can draw a circle inside the triangle in a way that the sides of the triangle are tangents to the circle. So if I talk about the point of contact PQR, let's say these are the points of contact, and if I locate the center of this circle, that is the incenter. So now this incenter, let me call I. If I join IP, IP will be a radius and BC is a tangent. So IP is perpendicular to BC. This is also perpendicular, this is also perpendicular. So then you see that IP, IQ, IR, these are again the radius of the circle, which is called in radius, and they're equal. And you see that AB, BC and AC, these are all at a same perpendicular distance from point I. So if the question is about what point is equidistant from three sides of a triangle, the answer is incenter. So that is that might be mentioned in some textbooks, but it is not mentioned in the syllabus list as such, but it's also important. Then for circles, again, there are a lot of theorems based on different properties, angle properties, cyclic properties, and so on. So for each of these theorems, you don't have to go through the proof of the theorem right now, but you just need to understand what the theorem is talking about. Given what information, what conclusion we can always derive. So questions will be based on a figure given to you, and mostly some angle measurements will be given, and you have to figure out what are the measurements of missing angles. So step by step, try to apply some of these theorems to find out the missing angle value. And whenever you're writing the steps, mention briefly. Suppose if you're talking about this theorem, just rephrase this with some keywords, because that will be required in your answer. Proofs generally will not be asked, so you don't have to look at them right now. And then some tangent properties are also there, tangent secant properties. A lot of theorems are there. So again, go through them, check the diagrams, check the explanation, and then given any question, try to apply them. And for geometry, do remember, try to remember whatever you have learned in previous grades also. Some basic theorems like Pythagoras theorem or some basic other circle theorems that you have learned maybe in grade 9. Maybe they might be required in some solution, whatever question is asked. Then again, construction is about construction of circles. So you have to construct tangents to a circle from external point. So there are some specific steps that you need to follow. Constructions, again, you have to always do with a scale and compass. And steps of constructions are not required to be written as such. Only if the question is asking to write some measurement, that you have to write below the construction, that length of this thing is this much centimeter, or this angle measures this much, so carry your protractor also for any angle measurement that might be required. Then you can have question on drawing a circumcircle or incircle, which is also known as circumscribing and inscribing circle for a triangle or a regular hexagon. So again, the steps are very specific. Just follow the steps and do the construction. And for any locus construction, anything based on locus, if the question is asking construct the locus of points equidistant from this and that, once you do the construction, it will be either an angle bisector or a perpendicular bisector. Below the construction, just mention that the locus of this and this is the perpendicular bisector or the angle bisector. So that is needed. So this is all for geometry. Then comes mensuration.